Section 9.4 is about finding inverses of matrices and solving systems of linear equations using the inverse of a matrix. Now, we're going to begin this section by looking at the definition of what is an identity. So, if you have a matrix n by n, with ones the main diagonal and the upper numbers and the lower numbers are zeros, then that is called the multiplicative identity of a matrix. Now, what does it mean by a multiplicative identity? Is if you think about numbers, an identity is a number that when multiplied times any other number, it doesn't change the value. So what number can be multiplied times anything else and it gives you the same number back? It would be 1. So the identity under multiplication is the number 1. So in a matrix, the number 1, it is being represented by the ones in the diagonals, the zeros below, zeros above. Also, that's in a 2 by 2 matrix, so we call that the identity 2, meaning the identity of 2 rows and 2 columns. Now, likewise, the identity 3, called the identity of 3 rows and 3 columns, is represented by ones in the three ones in the diagonal, and then zeros on the lower half and zeros on the upper half. So if I multiply any of these matrices times any other 2 by 2 or any other 3 by 3 matrix, they will not affect the value of those matrices. Now, definition of multiplicative inverse. Now, when a multiplicative inverse of a matrix is a matrix that when multiplied times the original matrix, it equals to the identity matrix. So if I multiply that matrix times its inverse, that's what the definition tells you here, then that multiplication must equal to the identity matrix. Likewise, either way, if I multiply it one way or if I multiply it the other way. Okay? So remember that multiplication of matrices is not commutative, but in the case that we're talking about the multiplicative inverses, if we multiply them one way and if we multiply them the other way, it will equal the identity on either way. Okay, so if a matrix has an inverse, then we say that it is invertible or non-singular. If any matrix does not have an inverse, then it is called singular. Now, one little thing that you need to keep in mind, as you can see here, so for inverses, it must be a square matrix. Let's go ahead and do the multiplication right here and determine if these two matrices are inverses of each other. Okay. So we have find the product AB and BA to determine whether B is a multiplicative inverse of A. So let's do it one way. Now right here we don't have to check the orders, just like I showed you on the previous section, because the two matrices have the exact same order. They're both 2 by 2s, and by definition the resulting is going to be also a 2 by 2. So we're going to multiply A times B. And we're going to get a 2 by 2 matrix, meaning 2 rows and 2 columns. Okay. So when we multiply the two matrices, remember that we are supposed to look at the location of each element. For example, this first element is located in the first row and first column. So in order for me to find the value of this element, we're going to multiply the first row of the first matrix, which is this one, times the first column of the second matrix, which is this one. And we multiply them in the order in which they appear. The first times the first, and the second times the second one. So if we multiply 11 times 11, that's going to give us a 121. And then plus the negative 10 times the 12, it's going to give us a negative 120. So 121 plus negative 120, it's going to give us a 1. Next one. Now this number on the right side, it is situated in the first row still, but in the second column. So if I want to find the value of that, what I need to do is multiply the first row again, which is this row, one more time, but now times the second column, which is this column on the right side. And we multiply them in order. It would be the 11 times the 10 plus the negative 10 times the 11. Now 11 times 10 is 110, then negative 10 times 11 is negative 110. So when I add them, they equal to 0. Now we're going to talk about the bottom ones. Now to find out the value of the bottom line right here, remember that this one is in the second row, but first column. So what we need to do is multiply the second row of the first matrix, which is this one, times the first column of the second matrix, which is this one. So we multiply the negative 12 times the 11, and then we multiply the 11 times the 12, and then we add the results. So this is negative 132 plus 132, and if I add them, they give me 0. Now we're going to do the last multiplication. This one is located in the second row, second column, so which means that in order to find the value, we're going to multiply the second row of the first matrix, which is this row, times the second column of the second matrix, which is this column. So it gives us negative 12 times 10 plus 11 times 11. Negative 12 times 10 is negative 120. 11 times 11 is 121. So negative 120 plus 121 gives us a 1. Now we're going to do the other side, BA. Now B right here is 11, 10, 12, and 11. And I'm going to multiply times A, which is 11, negative 10, negative 12, and 11. Again, we're going to end up with a 2 by 2, of course. So we're going to set it up in that same manner. So this is going to be a 2 row by 2 column matrix. So we're going to do the exact same thing. This number is in the first row, first column, so we're going to multiply the first row times the first column. So we're going to have an 11 times 11 plus a 10 times a negative 12. So this is 121 and this is negative 120. When I add them, they give me 1. Now if we look at the second one, this one is situated in the first row, second column. So we multiply the first row times the second column. So that would be 11 times negative 10 plus 10 times 11. So that's going to be negative 110 plus 110, which is going to give us a 0. Next, this one is in the second row, first column. So I multiply the second row times the first column right here, and we multiply the 12 times the 11 plus the 11 times the negative 12. That's 132 plus negative 132, which gives us a 0. And last but not least, this is in the second row, second column, so we multiply the second row, which is this one, times the second column, which is this one. So it would be 12 times negative 10 plus 11 times 11. This is going to be negative 120 plus 121, which gives us a 1. So based on this, what we got, what can we conclude? Since AB and BA both give us the 1100, which we call the identity. Both of them are the identity. So that means that these two matrices, A and B, are inverses of each other. That's what we're going to conclude. Therefore, A and B are inverses of each other. Period. Now, what would happen if either AB or BA or both, basically, does not give me the identity? Then we would say that they are not inverses of each other. In order for two matrices to be multiplicative inverses of each other, when multiplied, they should give me the identity back. Now, let's go through the process of how do we find the inverse given any of these matrices. So if I would have given you A, how could you find me B, the inverse of A? I'm going to show you that. Okay. So The process, there are two different ways of doing it. First of all, we're going to start with a quick method for finding multiplicative inverses only and only of 2 by 2 matrices. This method that I will show you right here doesn't work if the matrix is a 3 by 3 or higher. So if you have a matrix A, B, C, D, 2 by 2, we're going to call that matrix A. To find its inverse, which the inverse is denoted with the -1 power, so that means A inverse is going to be represented by 1 over AD minus BC. So it's 1 over, what does it mean by AD? Means multiply these two numbers in this diagonal right here. That's what AD is. Minus BC means multiply these numbers in this second diagonal right here. Okay, and that's for this value on the outside. This is going to be a number that ultimately has to be multiplied times every value inside of this new matrix that you see right here. Now, how do we find those values of that new matrix? Look at the setup. It tells you that AD, which is this diagonal, you're going to flip those values around. DA. So you're going to switch them over. And if you look at the B and the C, what does it tell you about BC? Negative B and negative C, meaning change the signs of those two values in that diagonal. This is just a quick way of finding the inverse of a matrix. Now, once you get these values in, you multiply them, like I said, times the number on the outside. Every value must be multiplied times this number. And that should give us the inverse. Now, one little thing and one little observation is this. If this number on the outside, the AD minus BC, gives me a 0, then the matrix does not have a multiplicative inverse automatically. That's what we would conclude. So that number on the bottom cannot give us a 0 because then that fraction would be undefined. Okay, which means that there will be no inverse. Now let's answer this question here of finding the inverse of this matrix. We got, use the fact that A equals AD, then A inverse equals 1 over AD minus BC times D negative B negative CA, or the whole formula. To find, this is the question, find the inverse of the matrix if possible. Then remember, we can check the answer by multiplying the matrix times its inverse, and it must equal the identity. That was what we did on the first question. So let's set this up. So the formula to find the inverse tells me, first of all, it's going to be 1 over A times D, meaning that you're going to multiply these two numbers in this diagonal. -4 times -4. Minus B times C means that we're going to multiply these two numbers in this diagonal. -5 times -4. Minus -5 times -4. And this is going to be multiplied times the new matrix. Now the new matrix, you can obtain it by first, these two values in this diagonal right here, the -4 and the -4, you're going to switch them over. So I'm just going to put them in different colors because since they're the same, right here is not going to matter. But you have to switch them, of course, if they're not the same. So right there, -4 goes here, and this -4 goes here, so you switch them. Now, these two values in this diagonal, you're going to change the signs. So -5 and -4 becomes +5 and +4. That's what it tells you on the formula. Now, let's go ahead and find the value on the outside. -4 times -4 is 16. -5 times -4 is 20. So 16 minus 20, it's going to be -4. So what we get there is going to be this. Okay, A inverse is going to be equal to 1 over -4, or -1/4, times -4, 5, 4, and -4. So to finish this up, what we need to do is multiply each one of these values by the 1 over -4. Okay, so that's what we need to do to complete this. So if I multiply 4 times 1, it's going to be 4, but when we divide it by the -4, it's going to give us a -1. Then 5 times 1, it's going to be 5, but when we divide it by the -4, that one stays as a fraction, so it's -5/4. Then 4 times 1, it's going to be 4, but when we divide it by the negative 4, it gives us a negative 1. And last, negative 4 times 1, it's negative 4. When we divide it by the negative 4, that's going to give us a 1. And this is the inverse of the matrix A. Now, you can always check your answer just by multiplying them, and it must equal the identity. So I'm going to show you the check of how we can check if it is correct. Okay? But I'm going to do the check only one way. So I'm going to do A times A inverse. I'm going to do that. I'm going to do it that way. So A being negative 4, negative 5, negative 4, negative 4 times A inverse, which is negative 1, negative 5 fourths, then negative 1 and 1. Let's see what we're going to get right here. So, remember how we multiply them. So this one is in the first row, first column, so you multiply the first row times the first column. So, and you multiply them in order. So it would be the negative 4 times the negative 1 plus the negative 5 times the negative 1, and that equals to 4. Let me see. Let me check this out. Okay, let's see, there was a little problem. I think it was on this side. Negative 4 times 1 is negative 4 over negative 4. That should be a positive 1. This is the only thing that I need to change. Everything else I think it was good. So, yes, because it wasn't giving me a 1. So now if that's a 1, then it would be negative 4 times 1 and then negative 5 times negative 1. So negative 4 times 1 is negative 4 right here. Then plus negative 5 times negative 1, which is positive 5. So negative 4 plus 5, it's going to give us a 1. So now it is fixed. So that's a 1. Now we're going to do the next one. The next one is we're going to multiply. To find the value on the right side, we're going to multiply the first row. This is in the first row, second column. So you multiply the first row here times the second column. So then we multiply them in order. It's the negative 4 times the negative 5 fourths, and plus the negative 5 times the 1. And this gives us negative 4 times negative 5 is 20 over 4. It's going to give us a 5. Plus negative 5 times 1 is negative 5. So negative 5 plus 5, 5 plus negative 5 is going to be a 0. Then, for this one on the bottom, this one is located in the second row, first column. So we're going to multiply the second row here times the first column here. So that's a negative 4 times 1 plus a negative 4 times negative 1. So it gives me a negative 4 plus 4, which is going to be a 0. Then for the last value, this is situated in the second row, second column. So we multiply the second row of this matrix times the second column of this matrix. So we do negative 4 times negative 5 fourths plus negative 4 times 1. Negative 4 times negative 5 is 20. 20 over 4 is going to give me a 5. Negative 4 times 1, it's going to be negative 4. So 5 plus negative 4, it's going to be a 1. And remember, this is how we can check them. In order for me to know that this answer is correct, when I multiply this matrix times its original matrix, the inverse times its original matrix, they must equal to the identity matrix, which is the 1, 1, 0, 0. Now, I'm going to show you now how you can find the inverse of a matrix when it is a 3 by 3 or higher. Okay. Now, the process, I'm going to explain it to you as we go. Right here we're going to do this problem. I'm going to show you the process how we actually find the inverse of a 3 by 3 or anything higher. Now, the 2 by 2 can also be done in the method I'm going to show you here, but again, it is going to be longer. So it is always easier to do the 2 by 2 using the formula. Now, this one is a 3 by 3, so we're going to find the inverse of this matrix by forming A equals identity and then using row operations to obtain identity equals B, where A inverse is going to be my matrix B, which is whatever I get on the right side. Okay, and then you can check it again by multiplying and then making sure that it equals the identity. So this is what the first step of the process for finding the inverse of a 3 by 3 is going to be. So we're going to write the matrix. And we're going to equal it. Equal it means we're going to put the vertical line to the identity matrix, which is 1, 0, 0, 0, 1, 0, and 0, 0, 1. That's for a 3 by 3. That's what we do. Okay. So, and then we're going to use row operations, just like I showed you in section 6.1 and 6.2, until we make every number on the left side into ones in the diagonals and zeros on the lower half and zeros on the upper half. So, we're going to begin by making, of course, following the process. The first step is to making that number a 1 on the top, but it is already a 1. So second step, we need to make the two numbers below zeros. Now the first one is already a 0, so we just need to make the last one a 0. Remember, we need to add it to the equation that has that we made into a 1, or we need to add it to the 1. So basically, we're going to use the addition process, which is we're going to add the first row to the last row. The last row, which is -5, -6, 0, 0, 0, and 1. So, if I want to make this a 0 right here, in other words, I wanted to cancel with the 1, so first thing we need to do for them to cancel is multiply this one by a +5, which is the opposite of -5. So that gives me a 5, -5, -5, +5, 0, and 0, and then we need to add it to this other row. So we add it to -5, -6, 0, 0, 0, and 1. So I'm going to write the operation that we used. We multiply +5. We multiply +5 times the first row, and then we're adding it to the third row. So let's do the addition right here, and let's see what we're going to get. So -5 plus -5 is 0, -5 plus -6 is -11, -5 plus 0 is -5, 5 plus 0 is 5, and then 0 plus 0 is 0, and 0 plus 1 is going to be 1. So then my third row is going to become 0, -11, -5, 5, 0, and 1. And then we're just going to bring down the other two rows, which is 0, 2, 1, 0, 1, 0 for this one, and then 1, -1, -1, 1, 0, 0 for that one. So we did the first two steps, which is we made the 1 on the top and we made the two numbers at the bottom zeros. Step number 3, we need to make the number in the middle into a 1. Now, how do we make that into a 1? We either divide by itself or we multiply by the reciprocal of 2, which is 1/2. So we can say row 2 divided by 2, that's what we can say, or 1/2 multiplied times row 2, which is the exact same thing. So we're going to multiply it by 1/2. So let's do it with multiplication. So 0, 2, 1, 0, 1, 0. So if I multiply by 1/2, remember that's the same thing as dividing by 2. What are we going to get? 0 divided by 2 is 0. 2 divided by 2 is going to be 1. 1 divided by 2 is 1/2. 0 divided by 2 is 0. 1 divided by 2 is 1/2. And 0 divided by 2 is going to be 0. I'm going to be scrolling down as we go. So this is the next thing we're going to get in the middle row. So the middle row becomes 0, 1, 1/2, 0, 1/2, and 0. And we're just going to copy down the rest of them. 1, -1, -1, 1, 0, 0, and the bottom row 0, -11, -5, 5, 0, and 1. Next step in the process. So we already did the 1 at the top, we did the zeros at the bottom, we did the 1 in the middle. So my fourth step in the process is making the bottom 11, negative 11, into a 0. And to make it into a 0, we need to add it to the equation that we made into a 1, which is to the middle row. Okay, second and third. So 0, 1, 1 half, 0, 1 half, and 0 is going to be added to 0, negative 11, negative 5, 5, 0, and 1. Now, in order for this negative 11 to cancel or become a 0, first we need to multiply the top row by the opposite, which is going to be positive 11. So we can make them the same number, first of all, with opposite signs. So it's going to give us a 0, 11, then 11 times 1 half is 11 halves. 11 times 0 is 0, 11 times 1 half is 11 halves, and 11 times 0 is going to be 0. Then we're going to add it to this row, 0, negative 11, negative 5, 5, 0, and 1. Okay, so we're going to add these, and we're going to get 0, 0. 11 halves minus 5 is 1 half, because this is 5.5 minus 5, which is 0.5. Right? 0 plus 5 is 5. 11 halves plus 0 is 11 halves, and 0 plus 1 is going to be 1. So we're going to write that down on the bottom row. This is what my new matrix is going to look like. So we got 0, 0, 1 half, 5, 11 halves, and 1. And I'm going to bring down the rest of the rows, 0, 1, 1 half, 0, 1 half, and 0. And the top row, 1, negative 1, negative 1, 1, 0, and 0. Next. So on the procedure, we make the top into a 1, we make the two bottom numbers 0. Step 3, we make this one a 1. Step 4, we make the bottom one 0. Step 5 is make the 1 half into a 1. So to make that 1 half into a 1, I don't want to say divide by 1 half, so the easiest way there is multiply by the reciprocal of 1 half. The reciprocal of 1 half is 2 over 1, which is 2. So I'm going to multiply the whole row 3 by 2. Now, one thing I forgot to put is the row operation here. So we multiplied 11 times row 1 plus row 3. Now let's move on. So now right here we're going to multiply everything in the third row by 2, which is the reciprocal of 1 half. Dividing by 1 half is the same thing as multiplying times 2. Okay, so we're going to multiply everything times 2 to make this 1 half into a 1. So 0 times 2 is going to be 0, 0 times 2 is going to be 0, 1 half times 2 is going to be 1, 5 times 2 is going to be 10, 1 half times 2 is going to be 11, half times 2 is going to be 11, and 1 times 2 is going to be 2. So that's what we're going to get on the last row. So my last row becomes 0, 0, 1, 10, 11, and 2. Then I'm going to copy down the middle row and the top row. So we accomplished the first 5 steps of the Gaussian elimination, but we want to do the Gauss-Jordan elimination because we need to make everything into 1s and 0s. Okay, so we did the first 5 steps. Step 6, we need to make this negative 1 into a 0. So again, the same way. In order for me to make it into a 0, we need to add it to the equation that we made into a 1, which is to the middle equation, to the middle row. Okay. So we're going to start with that. So 1, negative 1, negative 1, 1, 0, 0 is going to be added to 0, 1, 1 half, 0, 1 half, and 0. Now, what do I need to do so that these two cancel out? What do I need to multiply? There's nothing that needs to be multiplied because they're already negative and positive 1. So all I need to do is we need to add them. So that's the operation we're going to use to make that a 0. Add row 1 plus row 2. So 1 plus 0 is 1 right there. Then negative 1 plus 1 is 0. Negative 1 plus 1 half is negative 1 half. 1 plus 0 is 1, 0 plus 1 half is 1 half, and 0 plus 0 is going to be a 0. So this is what we're going to get next. My top row is going to become 1, 0, negative 1 half, 1, 1 half, and 0. And I'm just going to copy down the rest of them. 0, 1, then 1 half. Then we got the 0, 1 half, 0, and the last one is 0, 0, 1, 10, 11, and 2. At last, what do we need to do? We made everything into ones and zeros already, as you can see. 1, then the zeros, then the 1, then the 0, then the 1, and then the 0. Last step and seventh step is to make the two numbers above, negative 1 half and 1 half, both of them need to become zeros. So we're going to have to do two row operations right there, okay? Because we need to make both of them zeros. Now, on my first row operation, I am going to make this negative 1 half into a 0. I'm going to start with that. To make it into a 0, we need to add it to the equation that has the 1, which is to the third one. Okay, so I'm going to do 1, 0, negative 1 half, 1, 1 half, and 0 is going to get added to the last one, which is 0, 0, 1, 10, 11, and 2. Okay, so if I want to make that negative 1 half to cancel with the 1, first I need to multiply this one by the opposite, which is positive 1 half. So we're going to multiply, I'm going to put it here, multiply the row 3 by 1 half, and then we're going to add it back to the first row. So let's do the multiplication. 1 half times 0 is 0, 1 half times 0 is 0, 1 half times 1 is 1 half, 1 half times 10 is 5, 1 half times 11 is 11 halves, and 1 half times 2 is going to be a 1. Then we're going to add those values to these values, to 1, 0, negative 1 half, 1, 1 half, and 0. So when we add these, 0 plus 1 is going to be 1, 0 plus 0 is 0, 1 half minus 1 half is 0. Now 5 plus 1 is a 6. 11 halves plus 1 half is 12 halves, which is also 6. And 1 plus 0, it's going to be 1. So my first row, it's going to become 1, 0, 0, 6, 6, and 1. Now, let's do the same thing for the middle row. Now, if I want to make that middle row right here into a 0, then I need to also add it to the 1 on the bottom, to the equation 3. It's going to be 0, 1, 1 half, 0, 1 half, and 0 is going to get added to 0, 0, 1, 10, 11, and 2. So I want to make this a 0, so the first thing I need to do, so I need to multiply the bottom equation by the opposite, which is negative 1 half. So negative 1 half times 0 is 0, negative 1 half times 0 is 0, negative 1 half times 1 is negative 1 half, negative 1 half times 10 is negative 5, negative 1 half times 11 is negative 11 half, and negative 1 half times 2 is negative 1. So what we need to do at last is that we need to add it to this equation here. 0, 1, 1 half, 0, 1 half, and 0. And at the same time, I'm going to write the operation we use here. We multiply this the bottom row by negative 1 half, so which is the third row. We multiplied it by negative 1 half, and then we added it to the second row to get those new values. So that's a 0, 1, 0, negative 5. Now negative 11 halves plus 1 half is negative 10 halves, which is also negative 5, and negative 1 plus 0 is negative 1. So that gives us 0, 1, 0, negative 5, and negative 1. And then we're just going to bring down the last row, which is 0, 0, 1, 10, 11, and 2. So the numbers on the right side, it is going to be, after we make everything into ones and zeros on the left side, these values on the right side, they represent the inverse of matrix A. So this is my inverse, A inverse, which is going to be 6, 6, 1, -5, -5, -1, and 10, 11, and 2. And we are done. So this is the inverse of the matrix A. So next thing I'm going to show you on this same problem, I'm going to show you how you can find the inverse using the graphing calculator. Let's look at the procedure of how we would find the inverse using the graphing calculator. Okay, that's the inverse that we have. So we're going to go here on the original matrix. Now for the calculator, we have to go to second matrix first, which is second and the x to the -1 key. Then you're going to go to edit on the right side. You press enter. You're going to put the dimensions of your matrix, which we talked about dimensions in the previous section. So that would be a 3-row by 3 columns. So we're going to put 3 by 3. Then we put the values, which is 1, -1, -1. Then we have a 0, then 2, then 1. And last, we have -5, -6, and 0. After entering all those values, remember we have to go to second mode, which is second quit. Then we're going to go to matrix again, second matrix. Now this time you're going to press enter on the matrix that you edited, which is in this case matrix A. I press enter once. And to find the inverse, you're going to click on this key that has the x to the -1 power. And remember that that -1 power represents the inverse of matrix A. So then you press enter, and it gives us the inverse that we found. If we go all the way to the bottom, it should be the same thing. 6, 6, 1, -5, -5, -1, and then 10, 11, and 2. That is the inverse of matrix A. Now, I'm going to show you one more thing on this section today. So what we are going to do is, how do we find the solution using an inverse? How do we find the solution to a linear system, to a system of linear equations using the inverse of a matrix? Now it tells me right here, if AX equals B has a unique solution. Make sure that that's very important. What does it mean that AX equals B has a unique solution? That whatever system of equations you're trying to solve has only one solution, meaning one order pair or order triple. So just one solution. Okay, that's what the solution should be. Now, what happens if the system has infinitely many solutions or no solution? Then you will notice that you cannot solve the system using the inverse. You're going to get stuck into making the ones and the zeros. Just like I showed you before in the Gauss-Jordan elimination, on the last row, to find out that if you cannot solve it using the inverse, on the last row you're going to get a 0, 0, 0, 0, or 0, 0, 0, and a number on the right side. That automatically means no solution or infinitely many solutions. We won't be able to tell what it is using the inverse. So all we can say, if we get that, is that the system has no solution or infinitely solutions, so one or the other. So keep in mind, we can only solve systems using the inverse as long as the system contains only and only one solution. So if AX equals B, then X equals to A inverse times B. This is how we find the solution. Now what does X mean? X doesn't mean the variable X. I'm going to put the definitions here. A is a matrix. That A represents the coefficient matrix. X. That X doesn't represent the variable X, like I said. That X represents the variable matrix. Basically, if my variables are A, X, and Y, then that X represents X and Y. If my variables are X, Y, and Z, then that X represents the variables X, Y, and Z, and so on. Okay, and then matrix B represents the constant matrix. Okay. So now let's go ahead and look at the first type of questions. Before we go into solving, I want you to be able to find ax and b before that. Okay, so the first question we're going to answer is this. I want you to write a system of equations as a matrix equation in the form ax equals b, with A the coefficient matrix of the system, like I explained. So, right here, what is A? A is the coefficients, which is 3, -8, 5, 8, and then there's no y, so we put a 0, -6, -8, -3, and -6. That is my matrix A. Matrix X, it is my variable matrix, and my variable matrix means the variables of the system. We're going to put it vertically downward, and I'll explain that at the end why. So I'm going to put X, Y, and the last variable that we see there is Z. And then my matrix B is the constants. The constants are 7, -6, and -7. Now, if we want to write it in the form AX equals B, then this is how it's going to look like. A, which is 3, -8, 5, 8, 0, -6, -8, -3, -6, that's A, times X, which X is my variable matrix, X, Y, and Z equals to B, which is 7, -6, and -7. Now, why is it that I put them like this and not horizontally, like the second matrix, the X, Y, and Z? Because as you remember, we worked on the following. When you multiply two matrices, you multiply the row times the column. So remember, if I multiply the first row times the first column, that's going to give me my first equation that you see right here. 3 times X is 3X, -8 times Y is -8Y, and 5 times Z is 5Z, and that equals to the -7 that you see on the other side. Now if you continue, second row times the column, then it would be, it's going to give you the second equation right here, second row first column, right? 8 times X is 8X, 0 times Y, no Y, and -6 times Z is -6Z, and that equals to the middle one, which is -6. And if you do the last one, this is from the third row first column, so which is going to give you the third equation. -8 times X is -8X, -3 times Y is -3Y, -6 times Z is -6Z, and that equals to the -7 on this side. And you see that that's the reason we put it vertically, because when you multiply them back, it has to be row times column. We have to put them in the form of a column. Okay, so this is my setup in the form AX equals B. Coefficient matrix times variable matrix equals to the constant matrix. Okay, now with that said, I want you to try the following. Try it the other way around. Now I want you to write a system of equations from this matrix. So find me the first equation. To find the first equation, you have to multiply the first row times the first column, which is this, of course, right? And that equals to the first value right here. So -1 times X is -X. -7 times Y is -7Y. -6 times Z is -6Z, and that is equal to the first number, which is -6. Now we're going to do the second row. Second row times the column, it is going to give us the second equation. And of course that equals to the -3. -6 times X is -6X. 8 times Y is plus 8Y. 7 times Z is plus 7Z, and that equals to -3. Last but not least, third row times the column, it's going to give me my third equation, and that equals to 7, of course. We're going to do -2 times X, -2X. 7 times Y is plus 7Y, Negative 7 times z is minus 7z, and that equals to the third value, which is 7. This is a system of equations that will generate these matrices A times X equals B. And to finalize this section, we are going to answer one more problem here. We are going to solve the following linear system by using the inverse of the matrix. Okay, we're going to solve the following linear system by using the inverse of the matrix. So, first thing we got to do in this problem, we need to set it up so that it is in the form AX equals B. Okay, so we need to find A, we need to find X, and we need to find B. So A is the coefficient matrix, which is 1, 4, negative 4, and 2. X is my variable matrix. What are the variables here? X and Y only. And Z, it is a constant matrix, which is going to be 12 and negative 12. Now, remember that the solution, to find the solutions of the system, this is a formula. X is equal to A inverse times B. Oh, I forgot this one, I said B, but I put C. This is my B. So in order for me to find the solution, we need the inverse of A and then multiply times B. There's only one little problem. We don't have the inverse of A. So the first step in the process is that we need to find that inverse of A. It is up to you right here. Since this one is a 2 by 2, you can use either the formula or you can use Gauss-Jordan elimination. Okay? So you have the two different ways of doing it. It is up to you how you want to do it. Okay? So let's go ahead and do it with the formula. So with the formula, we're going to have 1 over A times D, which means you multiply these two numbers in this diagonal, 1 times 2, minus B times C, multiply these in 4 times negative 4. And this is going to be multiplied times. We're going to switch these two values in this matrix. 1 and 2 becomes 2 and 1. And then we're going to change the signs of these two values in this diagonal. So that 4 becomes negative 4, that negative 4 becomes positive 4. Change the signs. Okay. So let's see what that's going to give us. 1 over, this is going to be 2 minus, and that's a negative 16. So that changes to an addition right here. So that would be 1 over 18. Right? That's what we're going to get on the bottom. So we are going to multiply this fraction times each one of these numbers inside of this matrix. So if I multiply them, let's see what we're going to get here. So 2 times 1, it's going to be 2 over 18. We can simplify it, we can reduce it to 1/9. Negative 4 times 1, it's negative 4 over 18. We can reduce that by 2, and that gives me negative 2/9. 4 times 1, it's going to be 4/18. We can reduce it to 2/9. And last but not least, 1 times 1, it's going to be 1 over 18. It's going to stay as 1/18. So this is the inverse of matrix A. So we found the first part of the process. We found the inverse of that matrix A. So then that's this. What we need to do to find the solution, we need to multiply that times matrix B. And matrix B, we have it right here. So we need to multiply times that matrix B. So now we're going to do this multiplication. Multiply these two matrices, and that should give us the solution for X. X meaning the X and Y, right? So when I say X, variable X, matrix X means X, Y equals A inverse, which we already know what it is, 1/9, negative 2/9, 2/9, and 1/18. that's the inverse of A. We're going to multiply times matrix B, which is 12 and negative 12. If you look at the orders of these matrices, this is a 2 by 2, this is a 2 by 1, so we can multiply them because you see that the middle dimensions are equal. The number of columns of the first matrix equals to the number of rows of the second matrix. And then to perform the multiplication, remember we just check the first and the last. That will be the order of my new matrix. So my new matrix is a 2 by 1, right? Meaning that is going to contain only and only 2 rows and 1 column, one single column like this. And guess what? The first is going to be the value of X, and the second one is going to be the value of Y. Let's find that out. So, when in order for me to find the first one, it is located in the first row, first column. So you're going to multiply the first row times the first column, which is this. Okay? So you multiply the 1/9 times the 12 plus, and then the negative 2/9 times the negative 12, and then you're going to add the results. So this is going to give me right here a 12/9, and this is going to be a 24/9. If you add them, that's 36/9, but 36/9 is the same thing as positive 4. So that answer is my X. So we already know right here that X is equal to 4. Okay. Next, we're going to multiply. This one is located in the second row, first column. Second row, first column. So we multiply the second row times the first column. So it would be the 2/9 times 12 and the 1/18 times negative 12. And then you're going to add them. 2/9 times 12 is 24/9. Then negative 12, 1/18 times negative 12 is negative 12/18, which is negative 12/18 can be, I'm going to reduce it into 9s also, that's negative 6/9. Right? Negative 12/18 is negative 6/9. So when we add them, 24/9 plus negative 6/9 is 18/9, and that is equal to positive 2. So what does that mean? That the Y is equal to 2. So that is my solution. So we can write the solution as an ordered pair. The solution for this system of equations is the pair 4, 2. That's the point of intersection of those two equations. And this concludes section 9.4, which deals about finding inverses of matrices and solving systems of linear equations right here, like I show you, by using the inverse of the matrix, by multiplying A inverse times B.